Hello everybody. Today I am going to discuss in brief the characterization techniques like SEM and FESEM. Here you can see the two pictures related with the optical microscopy versus scanning electron microscopy. The optical microscopy characterizes the sample at a small depth with low resolution, and the SEM gives you the image with larger depth with high resolution. The scanning electron microscopy it generally uses the different imaging concept. High energy electron beam is used to excite the specimen, and the signals are collected and analyzed so that the image can be constructed. The signals carry topological, chemical, crystallographic information respectively of the sample surface. So this is the pictorial. You can see the representation of the machine generally they are using. So SEM is designed for direct studying of the surfaces of solid objects, and they uses the electrons rather than the light to form the images. So here you can see the comparison between the SEM and OM. So here you can see the clear-cut difference between the magnification and depth of field of resolution between OM and SEM. So SEM has a large depth of field which allow a large amount of sample to be focused at one time and produces an image that is a good representation of three-dimensional sample. The SEM also produces images of high resolution, which means that closely features can be examined at a high magnification. The combination of higher magnification, larger depth of field, greater resolution, and composition and crystallographic information makes these characterization techniques used in the research industry, especially in semiconductor industries. The main applications are to study the topography color entry, to understand the morphology, that is the shape and size of the particles making up the objects, composition, crystallographic information. So this is you can see the columnar view of the SEM system. Here you can see the electron guns, gun alignment control, pneumatic airlock valve, then condenser lens, objective aperture, scanning coils, objective lens. These are the different stages along with the sample chambers. So this is the more detailed look inside the SEM. These are the images. You can see with the various magnification, you can see the images through the SEM. Here you can observe the comparison between the OM, TM and the SEM. Okay, so in OM, basically they are using light, but in TM and in SEM they are using electron as a source. And here we have to remember one more point, that the SEM is used in SEM always used a vacuum in the sample chamber. So these are the various electron beam sources used in SEM. These are the, you can say, the electron beam interaction and the specimen interactions. So the sources of images information you are getting via different electrons, different types of the electrons. X-rays, auger electrons, then cathodoluminescence, secondary electrons, and the primary backscattered electrons are used to generate the images and to understand the different information. So you can measure or you can see the images with these various magnifications. The advanced technique is the field emission scanning electron microscopy is nowadays generally used to get the high resolution images, and along with the SEM images you can get the characterization like ADX, you can get WAX or so on. So here you can see the machinery used in FESEM. So its principal operation is that a field emission cathode in the electron gun of scanning electron microscope provides the narrower probing beams at low as well as high electron energy, resulting in both improved spatial resolution and minimized sample charging and damage. The field emission scanning electron microscopy provides the topographical and elemental information at a magnification in this range. So compared with the conventional scanning electron microscope, field emission microscope or the FESM produce clear, less electrostatically distorted images with spatial resolution down to 1 to 1.5 nanometers. So another advantages of FESM include the ability to examine smaller area contamination spot at electron accelerating voltages compatible with energy dispersive spectroscopy, that is EDS technique. Reduced penetration of low kinetic energy electrons probe closer to the immediate material surfaces, and due to this it will generate the high quality images. So application of FESM include semiconductor devices, cross-section analysis for gate widths, gate oxide, film thicknesses and the construction detail. Then it also gives us the information about the coating thicknesses, structural uniformity and so on. So these are the FESM images you can see, and you may compare the earlier SEM images with this FESM images. So here you can observe the clarity in the images to understand the surface behavior in detail. Thank you very much.